Istanbul earthquake yesterday, at 49 minutes after noon, the ground began to rapidly shake back and forth in Istanbul, Turkey, causing many people to panic. A strong earthquake had just struck around 45 miles or 72 kilometers west-southwest of one of the planet's most populous cities, registering in as a magnitude 6.2. Across the next 13 seconds, items fell off shelves, cracks formed in some structures, and one building home to no people at the time collapsed. While this was the strongest earthquake to strike the region since 1999, it thankfully caused at its most severe only moderate damage. And there is a key reason for this. The earthquake struck in the geologic setting middle of the Sea of Marmara, the body of water that links the Black Sea to the northeast and the Aegean Sea to the southwest. Thus, while the strongest ground motion yesterday's earthquake produced was MMI 7.5, the strongest ground motion on land was only MMI 6.5, specifically around the city of Korlu. Istanbul felt an MMI of 4, Ankara felt a 2, and portions of Bulgaria, Romania, and Greece also felt this strong earthquake. While as many as 50 million people felt this brief quake, only 9% of this total lived in an area with a theoretical potential for some limited structural damage to occur. And this is why early USGS modeling suggests no deaths occurred, and between $10 and $100 million in damage. Still bad to those who are severely affected, but it could have far worse. Yesterday's earthquake occurred on the major North Anatolian Fault, which marks the boundary between the Eurasian Plate to the north and the Anatolian Plate to the south. The Anatolian Plate is rotating counterclockwise while also moving to the southwest, while the adjacent section of the Eurasian Plate is moving to the east-northeast. Strain from this motion builds up on various fault segments, until finally a portion of it was released, creating yesterday's earthquake, which matches what would be expected from right lateral strike-slip fault. A specific 350-kilometer-long section of the North Anatolian seismic gap fault along with its associated fault zone has produced 20 magnitude, 6 magnitude 7, and 76 magnitude 5 or larger earthquakes since 1905. In other words, these are the recent average rates of various larger magnitude earthquakes on this fault line, so with this taken into account, yesterday's earthquake wasn't all that unusual. However, it is noteworthy for a different reason. This was the largest earthquake to have occurred on a specific segment of the North Anatolian Fault line which has not produced a major rupture since the 20th century began. Even with yesterday's earthquake, this segment has not fully ruptured, and I am mentioning this because broad statistical chances suggest that a magnitude 7 range earthquake has around a 50% chance of striking near Istanbul by 2030. And the specific fault line segment that ruptured possible future magnitude 7 yesterday is one of the better candidates for producing such a major quake. However, we absolutely cannot predict earthquakes, nor we can tell if an already sizable quake represents the foreshock preceding an even larger event. Per a direct quote from the U.S. Geological Survey, observations show that the chance of an earthquake being followed by a larger one nearby and within a week is about 5%. In other words, the most likely outcome is that no larger quakes will be triggered by yesterday's event. However, what is quite likely and has already happened are aftershocks of smaller magnitudes. Aftershocks: the statistically largest aftershock following a main quake is on average 1.2 magnitudes lower. And, what do you know, already 2 such magnitude 5.0 aftershocks have struck. These aftershocks should become less frequent as the subsequent days progress. As a final note, I would like to thank my new patron Brian Roch for supporting this channel.